3.1. Solve linear systems by graphing.
First, a solution would be an ordered pair, which is xy, that satisfies both equations, and it eventually is the point of intersection between the two lines. So we're going to start out by showing you guys how to graph a system of equations using the x and y intercepts. And this should be review. So in order to find the x-intercept, you need to plug in 0 for the y. And in order to find the y-intercept in an equation, you need to plug in 0 for the x. And we're going to start off by doing an example. Okay, so first you're going to plug in the 0 for the x value on this equation. And to solve for that, you would rewrite the equation, and then so you get y equals 8. And then you would plug in 0 for the y in order to find x. So you would get 4x equals 8, and divide by 4 on both sides, so x would equal 2. So now that we have both our x-intercept and our y-intercept for the first equation, we're going to plot those 2 points on the graph. So you go over to the x-axis and mark a point on the 2, and then on the y-axis you'll go up 8 and mark a point there too. And now that you have 2 points, you can connect the 2 points and make a line. So that is how your line would look for the first equation. Now we're going to go and do the second equation. So the second equation is 2x minus 3y equals 18. And again, we're just going to plug in the 0 for the x in order to find the y-intercept. So this would be 0 minus 3y equals 18. Then we would divide by -3 on both sides, and y would equal -6. And so then we would plug in the 0 for the other one, so it would be 2x plus 3 times 0 equals 18. And that would be 2x plus 0 equals 18. And divide by 2 on both sides to find x, so x would equal 9. Now we plotted both of those 2 points as well, and we're going to draw another line connecting those 2 points to each other. So after you have written both of your lines, you can see that they have an intersection point, which would be about right here. And from looking at the graph, you can tell that the intersection point is 3, -4. But in order to make sure that that is the correct solution, we're going to plug that back in and solve the equations algebraically. So now we have our 2 original equations and the solution, or so we think, but we need to check that. So you're going to plug in the x value, which is 3, for the x in the equation, and the -4 value in for y. And once you solve both of the equations, if they come out to be the same answer, then you know that the ordered pair that you found is your solution.
I'm going to show you how to solve linear equations by graphing using the slope-intercept form. So what you want to do is change the ax plus by equals c, dx plus ey equals f form into a y equals mx plus b form, where m equals the slope. So that would be a y over an x times x plus b. Okay, so we're going to start out with an example. So 4x plus y equals 8. 2x negative 3y equals 18. We want to change it into y equals mx plus b. Currently, it's at the ax plus by equals c form. So you subtract the 4x from both sides in order to get y by itself. So y equals a negative 4x, where the negative 4 is over 1, and the slope would then be a negative 4 down. You're going 4 down and over 1 to the right. And then you'd still have the point being 8 on the y-intercept. Over here, we have to subtract the 2x from both sides to get 3y equaling negative 2x plus 18. To get y by itself, divide by the 3. Now you have y equaling a positive 2 over 3x negative 6, because you have to divide the negative 3 from both sides of the equation. These cancel out, and you're left with a negative 6. So when we graph the equations, we're going to go up by 8 in order to find the first point. And then we're going to go down 4 and over 1. Down 4 over 1. Down 4 over 1. And then at that point, you've pretty much gone as far as you need in order to draw your line. And that's your first slope. The second one, you're going to go down 6 to find your point. Then you're going to go up 2 over 3. Up 2 over 3. Oh, look, there they cross. And there's your line. And there you can tell that your point is going to be 3, negative 4. In order to check it, just plug the numbers back in. It doesn't matter whether it's the original equation or not. We're going to use. So plug in 3 for x, and then the y value for both. Got 12 minus 4, that does equal 8. 8, and then negative 3 times the negative 4, that's going to equal 12 plus 6, that does equal 18. This equation is good.
So the next thing we're going to talk about is the possible number of solutions that you can have for a system of equations. So the first type of solution you can have is one solution, which is an ordered pair. So you should be able to tell that a system of equations will only have one solution just by looking at the equation. If the system of equations only has one solution, the equations will have different slopes. In the case of one solution, it doesn't matter if the y-intercepts are different or the same. It won't affect the number of solutions. So for an example, we're going to use the system of equations 3x plus 4 and 2x plus 6. We can see that the slopes are different, so we already know that we're going to have one solution. So after graphing, we can see that we have one point of intersection, which will be our solution, and that point is 2, 10. So the next possible solution you could come across is infinitely many solutions. Just by looking at an equation, you can tell that it will have infinitely many solutions because the equations will be identical when they are fully simplified. So they are identical in the way that they have the same slopes and the same y-intercepts when they are fully simplified. So here is an example of where your answer would be infinitely many solutions for a system of equations. So these might not look the same, but that's because the second equation is not fully simplified. So to simplify it, we're going to just divide both sides by 2, so then we have y equals 2x plus 1, just like the other one. So now we're going to graph this. So as you can see, after graphing, your answer will be infinitely many solutions because essentially when you graph the lines, they lie on top of each other, so they are the same line. So the third and final type of solution that you can get is no solution. So the reason that this is called no solution is because the lines will never intersect. So just by looking at the system of equations, you can tell that the solution will be no solution because the equations will have the same slope, but they will have different y-intercepts. So here's our example. It is y equals 2x plus 1 and y equals 2x plus 4. We see that they have the same slopes, which also means that they will be parallel. So let's graph this to make sure we are right. So as we can see, these lines are parallel, which means they will never intersect and never form a solution, leaving the answer to be no solution. This has been 3.1, Solving Linear Systems by Graphing.